So follow the series completely. Okay, let's start.
Firstly, sampling distribution. What is sampling distribution? You must understand that first. Sampling distribution is a process used in the statistical analysis in which the predetermined number of observations are taken from the larger population. Now, important word over here is predetermined number of observations. Remember this by heart. What happens? I must know how many samples I have to take. If I don't know that, then it would be of no use for me doing some sampling. I'll go on doing the samples. How many numbers I don't know. I'll take 500, then 1000, then 1 lakh. It won't end. So we must first decide where I have to stop. So predetermined number of observations are taken from the larger population. The methodology used to sample from a larger population depends on the type of analysis being performed. Now, understand this. Methodology means what? Here it means what type of sampling should I do. There we come with the topics of these random sampling, all the various types of sampling. I'll take them. Okay. So got it. Firstly, the concept. Okay. Okay. Now for a few things you need to understand. Sampling. Now suppose if I tell you to take some tea. Okay. I'll give you a cup of tea and ask you whether it's hot or not. What will you do? Will you take the whole cup of tea and drink it immediately to check whether it's hot or not? No. What will you do? You'll just take a sip of the tea. Sip, right? Hot. So if that sip is hot, it means the whole cup is hot, right? The whole tea is hot. That's the basic logic of sampling. I'll select those samples which will be indicative of the full population. Suppose if this is a city of 1 lakh, okay? Complete 1 lakh. If I do the sampling of whole 1 lakh, it is called a census. Understand the word. Census means when I do the sampling of each and every person. But when I am doing sampling as such, sampling word, when I am doing the sampling or survey, there I'll take the samples and I'll do the survey of those samples. I won't do the survey of all the population. Okay, got it? Simple. This is what the concept is here. You need to understand the concept first. Okay. Now look at this. Some important points over here. There are two parts. One is population and second is samples. Here, as I've showed you over here, this full circle is known as the population. 1 lakh people. And the samples which I take are known as, these points are known as samples. So this is the population as a whole and then we have sample. Now what are the terminologies used for the population and the sample? Look at it. Okay. Definition of population. Collection of all items. Full population. Suppose 1 lakh persons, as I told you over here. 1 lakh is the population of a city. So if I do the full population or survey of full population, it will be called as what? Then it will be called as census. And this is known as population. So it includes collection of all items. And here, part of the population, some part. Okay. What are the characteristics? Suppose if I take the mean mode of population, it is called as parameter. Suppose if I take the mean mode of sample, it is called as statistic. See here, mean, standard deviation of population is known as parameter. Mean, standard deviation of sample is known as statistic. We have various other statistics and these parameters. Mean, mode, median, all these are parameters as well as the statistics. Okay. Now how they are defined? Look at this. Size is always given as capital N is always for population. Small n is always for sample. Mean of population is shown as mu. Mu. Remember this is called as mu. And mean of sample is always shown as x bar. This you will see it when I will take the problems. Okay. There it's very important. Standard deviation is given as psi. This is called as psi. And here standard deviation is called as psi. But I'll tell you one more thing over here. Whenever I am taking anything for the sample, it is generally called as standard error. Remember this. If I have standard deviation for population, for my sample I have standard error. Okay. And we generally write it. You will see this when I solve the numerical. Psi dash. Okay. Psi dash. Okay. Now what are bias samples? Bias means what? Here we always say, no, this person is biased, My boss is biased. This is a general statement given by us, right? Boss is biased towards some employees, right? You have seen this. Suppose the parliament is debating on the women's bill. You are asked to conduct an opinion survey. Because women are most affected by the women's bill, you interviewed many women in different cities and towns and rural areas of India, rural areas of India. Then you report that the overwhelming 95% are in favor of the reservation of the women's bill. Now that is the bias sampling. If you ask only women about the women's bill, they'll definitely support it. Generally, that's a tendency. Okay. So that's a basic bias sample. So in here, what do we mean to say is that the population should be equally divided. If you are asking for those who are in favor, you should also ask for those who are not in favor. Okay. Otherwise, it becomes a bias sample. Now look at this. This sampling is of generally three types. 3 or 2 also we call it. Probability, purposive, and third is no rule sampling. Now no rule is generally not asked in exam. Probability and purposive is asked many times. Purposive is also called as non-probability. It is also called as judgmental. Here I'll write the words over here. Okay. It is non-probability also they call it non-probability. I'll just write non-prob. Okay. And next one is judgmental. Judgmental. Okay. That is also the another name to purposive. Now probability samplings are of 4 types. Simple random, systematic, stratified, and cluster. Now we'll study each one in detail. But before going ahead, I'll just give you the short idea about this. Simple random and all those. Okay. Understand one simple logic of probability. Probability sampling means that sampling in which every element has got an equal chance of getting selected. Equal chance. Okay. So every person, every individual, every sample will have equal chance. Now it is of 4 types. Suppose if I say in a class of 50 students, any 10 students, that becomes simple random. If I say every 5th student, means what? I'll tell them to stand in the row. I don't know. I'll close my eyes. I won't tell who will stand where. I'll close my eyes and tell them stand in the row and every 5th student come out. So that is all. That is known as systematic. Suppose if I divide that class of 50 students into marks, those who have got 40 to 50% stand here, 50 to 60 stand here, 60 to 70 stand here, and so on. So that will be called as stratified. I am creating strata, I am creating levels over here. Okay. And last one is cluster. Suppose if I tell them, those who are from Maharashtra stand here, those who are from Delhi stand here, those who are from Tamil Nadu stand here, those who are from this any state stand here. Okay. So this is generally cluster. Cluster is generally related to region. Okay. Now one important point I'll give you over here only, stratified and cluster. Within the same strata, they have similar qualities. Means what? 70 to 80% student, the student who is having the range of 70 to 80 will think similarly. They'll think similar to each other. Versus students who are having the marks 70 to 80 and the marks of 40 to 50. Their ranges will be different. Thinking ability will be different. So that's what is meant by stratified. 40 to 50% student will always think of passing. 80 to 90 will always think of scoring. So within the same strata, they'll have similar qualities. Within different strata, different qualities. Reverse is the case with cluster. Within the same cluster, there is a huge variety. Now somebody is from Goa. So in Goa also there will be a student of 80 to 90%. There will be a student of 40 to 50%, right? So within the same cluster, there is huge variety. It's exactly opposite of this stratified. Within different clusters may have similar qualities. Different clusters may have similar. Means what? Goa will also have some student who is 40 to 50 and MP will also have some students who is 40 to 50. UP will also have that, right? So within different clusters, we may have the students of similar categories. That's what is the difference between stratified and cluster. This question comes every time in the exam. Okay. Now, more about this non-probability. See this. I'll tell you later also. I'm having a separate slide on this. Convenience sampling, consecutive sampling, quota sampling, purposive sampling or judgmental, and snowball sampling. I'll give you a separate slide on this now only. Okay, and then we'll study each one. Now, simple random. We'll go in details now for probability because that's very important. Simple random sampling selects the samples by methods that allow each possible sample to have an equal probability of being picked and each item in the entire population to be included. Means what? Each possible sample to have of having equal probability means what? Just now I told you, any 10 students from the class of 100 students, any 10. So everyone has got a chance. So that's what is meant by simple random sampling. Each possible sample, see this, each possible sample will have equal chance. Very important part over here. Okay. I'll mark this. Hold on. Each possible sample, this one, has an equal probability of being picked. Okay. And each item in the entire population to be included in the sample. Correct? Now let's look at this for simple random sampling. Suppose if I give you this example. There are 4 teenagers, A, B, C, D. Any boys, you, anyone we can consider. Now I have to select a group of 2. How will I select? Group of 2 can be selected in these ways. AB, AC, AD, BC, BD and CD. This is the only way which I can select. Right? This you are having a separate topic of probability. There we'll study this again. Okay. So these are the groups I have selected. Now the question over here is probability of drawing these samples of 2 people is same as below. So means what? Suppose if the probability of selecting any 2, this BC or BD or AC, I close my eyes and I tell them to stand in these groups. And what happens? I close my eyes and select any group. Then what is the chance? Suppose if I want to select BC. Out of these 6, BC can be selected in only one way. So look at this. Probability of BC is 1 by 6. Similarly others. CD can be selected in only one way. So if you want to select the group, the probability is 1 by 6. Now look at this. This is separate. Suppose if in this group I make them to stand in group of 2s. And what is the probability? That I'll select A in this. Any group which I select, what is the probability that I'll select A? Single person. Now look at this. A can be selected in how many ways? AB, AC, AD. In all these A's there. So A can be selected in 3 ways, right? 1, 2 and 3. 3 groups. Out of how many? So 3 divided by 6. Now look at this. Very important part. This becomes a technical part. Okay. So A can be selected in 3 ways. 3 ways upon total 6. So 3 upon 6 is 1 by 2. So here comes the answer of 1 by 2. This typically is related to probability required upon sample size. Means success. I'll write it over here. Probability's formula is like this. Success upon sample size, SS. Okay. We'll study this when we study probability. If you want to write A, B, C or D on 4 identical slips of paper. Now here comes the next topic of this within the same random sampling only. The next topic which comes is sampling without replacement and with replacement. Now this common sense you can understand this. Without means what? I'll take 4 papers, 4 chits A, B, C and D. Okay. And slip of papers, fold the papers, randomly pick any 2. Suppose if I select any 2. And then what do I do? While picking up 2 slips, we may pick 1 by 1 and keep it away. Pick another from the remaining 3. Now remaining 3, what does it mean? Once I pick 1, I won't keep it again. So that's known as without replacement. And the second thing is with replacement. Suppose if I pick this slip D, okay, see the name in this and again put it inside that same jar. So then it will be called as what? With replacement. Don't we have this? We have seen this many times, right? With and without. Whenever I take any slip, I don't put it back in that box or whatever it is, right? So that is without. And this is with. We use the term infinite population now because this infinite population term is asked in the exam. When we are talking of about a population that could not be enumerated in reasonable time period. Now, what do you mean by this? Infinite means, what do you mean by infinite? Suppose if I say 1 lakh population, even I can call that also infinite. I say 1 crore population, I can call that also infinite. Although it is countable. Infinite, what is the real meaning of infinite? Which cannot be counted. But if I say 1, I'll tell you, okay, tomorrow I'll tell you. You go and count the entire population of the city, wherever you live. Is it possible? That becomes infinite for you within reasonable period of time. Okay, so it cannot be determined within reasonable period of time, right? Thus, we use theoretical concept of infinite population as an approximation of a large finite population. Approximation of large finite. Got it? If my population is too huge to be done in a survey, so okay, I'll give you one more example in this. I'll tell you what you do. You do the survey of 1 lakh people in 2 days. 1 lakh people in 2 days survey. Go and ask each one. It's not possible. That's a reasonable period. So that becomes an infinite population for that 1 lakh people for that 2 days. But if I ask you the separate question, now same 1 lakh population, I'll tell you to do the survey in, let's say, 10 years. 1 lakh in 10 years. Then it doesn't become an infinite population because there the time period is huge. That's the logic. Okay. So there is nothing called as absolute infinite or finite over here. Okay. Systematic sampling. In the systematic sampling, elements are selected from the population at a consistent level that is measured in time, order, or space. Now, consistent level. What do you mean by this? Just now I told you when I gave you that separate this slide I showed you. Every fifth student in the class of 60 students, every fifth student will stand in the row and every fifth student will come out. So that's known as systematic sampling. So consistent, okay. Systematic sampling differs from simple random sampling that in each element, in that each element has equal chance of being selected, but each sample does not have an equal chance of being selected. Now, this is a problem with systematic. And this question comes in exam as a complete the following for 1 mark. Systematic sampling differs from simple random sampling that each element has got an equal chance, because I don't know which element will stand on the fifth of this means whenever I tell them to stand in the row, who will be standing fifth? I don't know. So that means each element has got an equal chance, but each sample does not have, because the one who will be standing fourth, he will not get selected. So each sample does not have an equal chance in systematic sampling. In systematic sampling, there is a probability of introducing an error into the sampling process. The system chosen may cause a problem. Now, these are all the complete the following questions or match the following questions. They'll give you systematic sampling. Then on the other side, they'll give you the probability of introducing an error. This is what is an important part in the systematic sampling. Remember this from the match the following or theoretical part. Okay. Advantage. This method may require less time and sometimes results in lower cost than simple random sample method. Right? Because systematic sampling, obviously we are not telling all the 60 students to stand and select randomly. We are telling every 10th or every 5th. So it means it will give me a fair chance and it will be fast over here. Okay. Stratified sampling. To use stratified sampling, we divide the population into relatively homogeneous groups called as strata. Now, what do you mean by this homogeneous? When we divided those students 40 to 50%, 50 to 60%, right? We did it just now. 40 to 50, 50 to 60. So what were we doing? What did I tell you at that time? Suppose somebody has got a percentage of 40 to 50. They will think in the similar way. But the one who has got a percentage between 90 to 100, the thinking of these two persons, these two groups will be totally different. But within the groups, they will always think similar. So this is known as homogeneous. Thus, when we use the then we use the following of the two approaches. So first we'll divide them into separate strata. Then either we select at random from each stratum a specified number of elements. Means specified means what? I may tell that from 90 to 100 we'll select 5 students. From 40 to 50 we'll select 10 students. So I might have already decided. That's why come back to the first definition of that sampling distribution, predetermined. Okay, I'll say 90 to 100 I want 5 students, 40 to 50 I want 6 students, 50 to 60 I want 10 students. It will be determination from my side. That is one way out. And second way out is we draw equal number of elements from each stratum and give weight to the results according to the stratum's proportion in the total population. Okay, so I can draw specified number from each separate group, or I can draw equal number. Every group 40 to 55, 50 to 65, 60 to 75 and so on. So equal number or specified number. When to use stratified sampling? When do you use this? Stratified sampling is used is an appropriate when the population is already divided into different sizes. Means already I have divided 40 to 50% marks, 50 to 60 I have divided. Then stratified sampling is useful. Okay. Example, middle class, upper class, lower middle class. So I have divided this already. So then stratified sampling is of use. According to age, race, gender or any other stratification, age groups may be 13 to 20, 20 to 30, 30 to 40 and so on. Right. The advantages of stratified sampling are that when they are properly designed, they more accurately reflect the characteristic of the population from which they are chosen than any other kind of sample. So basically it is correct. Suppose if I choose 20 to 30 age group, so that thinking will give me the correct picture. Suppose if I want to design a jeans, okay, jeans pant. So which group thinks in what way? For that I have to divide it into various age groups and then I'll get the real answer. So that is that there the stratified sampling will be of best use. Cluster. We divide the population into groups or clusters and then select a random sample of these clusters. So first we'll divide them into these groups or clusters. What did I say earlier? It is similar to that of that regional geography based Goa, MP, UP. We assume that these individual clusters are representative of the population as a whole. Now, how do we do this? Now, this again you'll get this. What did I say earlier? Goa, MP, UP. We take a city map and divide the territory into blocks, right? So instead of city, I can take India map complete and divide it into various states. So it means again we are coming to geographical distribution and then choose a certain number of blocks for interviewing. Out of this, I'll choose which state should I interview the best or which area should I interview the best. Every household in each of these blocks would be interviewed, right? Comparison of stratified and cluster. Already I have given you. We use stratified sampling when each group has a small variation within itself, right? Stratified 40 to 50%, 50 to 60, 60 to 70. But there is a wide variation between the groups, right? 42% thinking, 40 to 50 thinking differently than 80 to 90, right? We use cluster sampling in the opposite case. When there is considerable variation within the group, Goa, MP, UP, but groups are essentially similar. Means in Goa also I am having 80 to 90%, in UP also I am having, in Tamil Nadu also having, everywhere, right? Basis of statistical inference. Simple random sampling, systematic sampling, systematic sampling and stratified sampling and cluster sampling. So basically systematic, stratified and cluster sampling, okay, attempt to approximate simple random sampling. So understand this concept. This concept is, let me cancel this. This part is a heading. Okay, yeah. So systematic sampling, stratified sampling and cluster sampling attempt to approximate simple random sampling. This is an exam question. In exam, they'll ask you Systematic sampling, stratified sampling and cluster sampling will attempt to approximate dash, and then the answer will be simple random sampling. Remember, these are the practical questions asked in the exam. The process of making statistical inferences is based on the principles of random sampling. Very importantly, remember, simple random sampling is the best sampling available in throughout the world. All these systematic stratified cluster are taken later. They are an approximation. Now I'll come to the second part. This was all that probability. Now this is non-probability. Now what is this? Let's see. Purposive sampling, also known as judgmental, selective or subjective sampling, is a form of non-probability sampling in which the researchers rely on their own judgment when choosing the members of the population to participate in the survey. So this is all judgmental. Suppose we see in that what TV shows, singing competition, dancing competition, what Naj Baliye, right? All those are there. No? What do we see in that? There are judges. Judges have their own judgment. They are the learned person. So, in form of non-probability sampling, where the researchers rely on their own judgment, own knowledge. So, this is judgmental sampling. Non-probability sampling is a branch of sample selection that uses non-random ways to select group of people to participate in the research. Non-random ways, okay? It's based on the judgment, simply, completely on the judgment. Now some other samplings, and these are also judgmental only. Snowball sampling is a non-probability sampling method where new units are recruited by other units in form of, to form the part of the survey. So this snowball is asked every time in the exam, every time. This is similar to that of MLM, multi-level marketing. You know that, no? You say you do one person, then that person will do 3 persons, those 3 will do again 3, goes on and on and on, right? So that is the same way. Where new units are recruited by other units to form the part of the sample. Second is convenience sampling. Convenience is the cheater. Who is the cheater? Is a non-probability sampling method where units are selected for inclusion on the sample because they are easiest for the researcher to access. What do I mean by this? Suppose if you tell me to do the survey of 15 persons in the city, 15 persons. And what do? I sit at my home. Who will go, man? Who is near me? Neighbors. Bring all my 15 neighbors and my family members. So that's convenience. Okay, because they are easiest for the researcher to access. Quota is a non-probability sampling method that relies on the non-random selection of predetermined number of proportion of units. Okay, so non-random selection of predetermined number. Predetermined. Quota means what? Mumbai 100, this Delhi 100, this what UP 100. So quota means what? A quota is given to everywhere. Consecutive. This is a sincere guy. Sincere. This guy is a cheater. Convenience. And this is a sincere guy. It's very similar to convenience sampling, except it seeks to include all accessible subjects as a part of the sample, which sometimes are considered as the best type of non-probability sampling. So this guy won't stay at home. He will go to each and every accessible part. 15 people, I'll go to one corner, then other corner, then other corner, and then I'll select the 15 samples from there. So this is consecutive. Sincere guy. Okay.